Hi, my name is Ellie Hummel, and I'm super excited to talk to you all today about calorimetry. But before I do that, let's dive into a chemical reaction. So in this chemical reaction, you have two common household products, baking soda and vinegar, and they react to form carbon dioxide gas, water, and sodium acetate, which is soluble in water so it dissolves into its ions. And in this reaction, energy is absorbed by baking soda and vinegar in order to break those bonds. And then energy is released in the products as they form new bonds. But in this particular reaction, more energy is absorbed by the reactants than is released by the products. So this makes it endothermic because it's absorbing energy from the surroundings instead of releasing energy into the surroundings. If a reaction releases energy into the surroundings, it's exothermic. So let's watch this endothermic reaction in action. So you can see that the baking soda goes into the vinegar, it heats up, and it releases the carbon dioxide gas, which fills up the balloon. And if you were to touch this, it would feel cold. Let's say we wanted to tell exactly how much energy was absorbed from the surroundings. We could do this with a process called calorimetry. In calorimetry, we use something called a calorimeter, which allows us to measure the amount of heat that is lost or gained by the surroundings in a system. Specifically, we would use the equation Q, which just stands for heat, equals mass times the specific heat capacity times the change in temperature in Celsius, of course. So let's dive a little bit deeper into what a calorimeter actually is. It's an insulated, enclosed environment, so heat is not supposed to be able to escape the calorimeter. As you can see here, the more scientific-looking machine is a bomb calorimeter. This measures combustion reactions, so it's not something that I would have in my house. But what I do have is two styrofoam cups, which is great because styrofoam cups are insulators. So this means that if a reaction were to occur in these styrofoam cups, I could use it like a calorimeter. So I have my insulator, I have my top, which is an important part of the calorimeter because you want to make sure heat isn't escaping through the top. And then in the calorimeter, I would have a water bath, which would be my surroundings, and then my reactants, which would be my system. I would also have a mixer to stir the reaction to make sure it's going to completion, and a thermometer to track the temperature of the surroundings. And the thermometer would normally be elevated, but I don't have that. And so let's just look again at why this calorimeter works. It's because of the law of conservation of energy. Because the calorimeter is an enclosed environment, no heat can be lost to the world outside of the calorimeter. So what happens is that the Q reaction, or the Q of the system, is equal to the inverse of the Q of the surroundings plus the Q cal, because, I mean, let's be honest, styrofoam cups aren't perfect and some heat does get out. But this basically sums up why we can find the heat released by a chemical reaction using calorimeters. So calorimetry is pretty important, outside of the fact that it can help us do things like use Hess's law and examine chemical reactions. It's also really important in drug development, like finding the melting temperature of certain drugs, like insulin needs to be cooler. And it also determines when proteins denature in drugs. So like if a protein denatures, its function changes completely and the function of the drug changes completely. So you obviously don't want to be giving someone a drug in which the proteins are denatured. So it's really important for drug development. It also helps us determine how many calories are in our food and things like the melting point of metal and the efficiency of fuels. So some tips and tricks for being successful in your calorimetry career. If you're using corrosive materials or dangerous things, or just like in the lab in general, it's always smart to wear PPE. I don't have goggles, but I do have this face shield. And gloves, especially if you're using something like hydrochloric acid or things that are kind of corrosive to you and others. Also, it's important to prepare, read up on the chemicals you're using before the lab so you can ensure the proper precautions are used. Also, if something's particularly dangerous, you want to do it in the hood, because the hood is an enclosed environment and so the reaction won't be endangering other people in the lab. Additionally, for efficiency, you want to minimize the time that the lid of the calorimeter is open because this releases unnecessary heat into the surroundings. Additionally, you want to make sure you stir your calorimeter to make sure the reaction is going to completion. And finally, you want to elevate the thermometer so it's not touching the bottom of the cup and it's measuring the surroundings, not anything else in the cup. So thank you. This is not a titration presentation, but this is the end point. Here's my bibliography, and I hope you have a great day.